screen. We're sharing the full, oh, start full screen. There we are. This Hangout is now live. Look. Okay. You guys just are not impressed, are you? Okay. We don't need to talk about the objectives because we're going to cover the objectives. So in chapters 5 and 6, we'll start developing the logical model of the proposed system and document the system requirements. So logical model shows what the system must do. So what are we talking about here? Okay, this is where I stop and you guys actually say something. So let's try that again. What are we talking about here?
System requirements.
Well, we've already done the system requirements. So we're through the system requirements. Now we're getting ready. We're at the point where we're ready to start the first step in building the system and actually defining what the system will do. Does that make sense? Okay. Who needs to know what the system's going to do? Everyone. Most importantly, programmers. Programmers, right? So let's talk construction, okay? So what do we need to build a house? Blueprints, right? How did we define what went on the blueprints? Whatever the architect designed. All right, we'll go further. Who decided what the architect should design? The user, in our case, the customer, right? The customer said, I want a small bedroom, a bigger living room. I want a smaller living room, bigger bedroom. I want this on the first floor and this on the second floor, right? And then the architect went ahead and developed plans. That's what we're doing here, okay? We're developing the plans. We're developing the plans for whoever needs to build it, right? So the physical model describes how the system will be constructed. Now, realize some of these terms can be a real challenge because we're not talking about having a physical blueprint, but when we're done with the requirements, okay, and we're done with creating these logical models, isn't that what we have? What do y'all think? Yes? Yes. All right. I'm going to start bringing a pot of coffee and shoving it down y'all's throats. So data process modeling. So systems analysts use graphical techniques to describe an information system. So one of those is a data flow diagram, a DFD. So it uses various symbols to show how the system transforms input data into useful information. Okay. So we'll be looking at these. And we've got a couple old, archaic, but still very valuable videos to take a peek at. So a data flow diagram shows how data moves through an information system, but it does not program logic and processing steps. So all we're saying is we have this element of data, we have an input, we have a desired output, we have some process, right? So the great example of this as we do this is as we start creating these processes, they really are black boxes, okay? So let's talk about Banner as an example. So Banner has this process that at the end of the term, it's going to calculate your current GPA, right? Do we know how it does that? Does anybody here know exactly how it does that? Do you have an idea? It averages your grades, all right? But when the programmer gets ready to design the program that does that, are we telling the programmer exactly how to do that? Or are we just perhaps telling the programmer we need something that averages grades, right? And then we leave it up to the programmer to give us what we need, right? Now, if we just say we need something that averages grades, we might get a lot of possibilities, right? But if we really define what that means, are we giving the programmer more information to do more exact of what we need? Yeah, okay. But in this process, a lot of these processes are black boxes in the fact that we know something needs to happen to the data, but we don't necessarily need to define exactly how it happens. You see the difference? Okay. So a set of DFDs provides a logical model that shows what the system does, not how it does it. Okay. So here's some symbols for data flow diagrams. Okay. So we will be using the Gain and Sarsen symbols to create data flow diagrams. Okay. So what we have here is some process. We need a calculator process. Okay. Does that make sense? We need a process to apply payment. We need a process to withdraw funds from checking. All processes, right? Do we have to know how it's being done? No, we just know it needs to be done. Okay. We have a data flow. So that's data that's going to flow in and out of a process. A data store. Okay. How many of you have taken the database class? A database class? Okay. So a data store is a table, right? We store the data in a table so that we can go back and reuse it. Okay. And then an external entity is pretty clear. An external entity is something outside the system, but that will interact with the system. Okay. So if we have a transaction processing system, what we've talked about. So we have this zero process called the transaction processing system. So I'd ask, what are some external entities that would interact with that transaction processing system? Customers. Okay, so a customer, there's a good one right there. Customer, right? External entity. What else? Employees. Okay. You know, they may need to go in and adjust quantities, give credits, debits, run reports. How many widgets did we sell? Yeah, employees. And right now we could lump in employees, we could lump managers in there, right? But as we start leveling these, we're going to provide more detail. The ultimate goal is to provide the most minute detail of the system. Okay, so that a programmer has everything they need to program the system. So I'd ask you to just consider, look at the functionality of Microsoft Word and all the processes it does. Can you imagine designing a data flow diagram for Microsoft Word? No? Okay, we won't do that in class today, I promise. All right, we'll be here for a while. But you get the ideas. How about some other entities? We're dealing with money. What kind of a bank? We might have a bank that we're withdrawing money from, right? Saying, hey, this person used their debit card from US Bank. Hey, US Bank, I need $29.95. And then I might have a bank, my bank, where I'm making electronic data interchanges, right, into my bank. So I might have multiple banks. But at the top level, we can just call it the bank. Anyone else? Vendors. Aha, vendors. Yep. It could be that vendors, you know, we were talking about a specific part of the system, right? The transactional part. But there's probably an inventory part too. And maybe what we do is give access to vendors so that vendors can see when we're low on the products that they provide us so that they can restock us, right? Instead of us having to call up and say, hey, I need, 400 of these widgets. Is that efficient? Do you realize that's how Walmart does it? If you want to be a vendor for Walmart, you have to provide a way for them to link into your system. You have to have a system. So the process symbol receives input data and produces output that has a different condition, form, or both. Now let's be careful with this, because can we have a process that just checks to make sure the data is in the correct form, okay, or meets some sort of data integrity rule that we've set? Yes? All right, I see a couple heads. The answer is yes. Contains the business logic, also called business rules, okay? So, and referred to as a black box. We don't know what happens inside there. We don't necessarily need to know. We just know something needs to happen to the data. So data flow symbol represents one or more data items, okay? So the symbol for data flow is a line with a single or double arrow. What's the arrow represent? Not necessarily the order. The direction that the data is going to flow, right? Is it possible that we have a process where data would flow out of it and then the same data might flow back into it? Y'all want an example of that? Okay, so an example of that would be a tax table. I have a process that says calculate taxes. Okay. What I need from that is some input on your hours, your, what deductions you declare. Are you single? Are you married? What are you, right? Then I go to the tax table and I say, tax table, give me the tax rates based on this information. And it can flow back into the process to then calculate what needs to be done, right? Or we can have a process that says, get this data, okay? A process that goes out and says, get me the tax table data, and then another process that says, now calculate it, right? So you see how those levels would go? Okay, so we submit work, grade student work, we have graded work, and student grade. So out of something that's submitted, we can have multiple outputs of data. So if you think about it, the first time a customer places an order on your website, and you have this process called process order, okay? Are we going to put the customer data in the same table as the order? I heard no. Why not? Oops. Hold on, Chad.
You want to be able to pull that data multiple times, the customer data.
I want to pull the customer data multiple times, right? And I only want to store the customer data once. What was your point? Was that kind of your...
I was going to say, I guess I'm in the database class now, so I was just thinking we were talking about in there how splitting everything up into different tables. Is that way when you're deleting or entering information, you don't get as much redundancy in the information, and it's easier to maintain.
Exactly. And we'll talk about that later in the term. It's called normalization, and the more we normalize the table, the whole idea is to normalize data down to, if we can, storing the data only one time. Now, sometimes we may create temporary joins, temporary tables, where we join data together so that we can query the joined data, because it's faster than saying, hey, get me data from here and data from there and data from there and data from there, right? So we create this join table. So different types. So DFD symbols, so data store symbol, okay? The data store symbol represents data that the system stores, okay? So a lot of times, if you notice, they have here, post payment. We have daily payments, prepared deposit, right? And once we have all of those daily payments, do we keep those daily payments in a daily payment table? What do you think?
Yes.
We could, okay? And then start a new table for the next day? We could. That's going to create a lot of tables, though, isn't it? What if we had a process that says, not only prepare deposit, but move end of day, take all those daily payments. We've made the deposit. We close the day, take all those payments and put them in our check register, as a deposit with sublines of each deposit. Does that make sense? Okay. So the physical characteristics of data store are unimportant because you're only concerned with the logical model. So we just need a place to store it. We are yet at the point of defining what is stored, how it is stored, and what we accept as data. Okay. So let's look at some data flow diagrams, some possibilities here, and let's figure out if this works. So, you know, entity, so the name of the entity appears inside the symbol, okay? Terminators, where things stop, okay? A source, where we're getting it from, okay? And a sink, okay? What we're doing with it. So let's look at this. Can we have data that flows from one process to another? Okay. Because do I need to store the data between two processes? Huh? Potentially, but let me give you an example. Let's go back to our tax table example. Okay. I've gotten the information, received, hours, classifications, etc. from employee. I now want to move that data into process paycheck. Do I need to store that data before I process the paycheck? Potentially, right? But I don't have to. So I can have data that flows from a process to a process. I can have data that flows from a process to an external entity. Produce invoice. Who's going to get the invoice? Customer, whoever placed the order, right? I can have data that goes from a process into a data store. So I have new customer information, and I want to store that for next time the customer comes in. Do I want the customer to have to enter all their information again? Nope. Associate that with a nice hefty username and password, right? Encrypt their personal data, and off I go. So why can't I have external entity to external entity?
External entity interacts with the process.
With the process or with the system, right? So consequently, if it's an external entity to an external entity and my system isn't involved, then let them handle it themselves, right? Yeah. An external entity to a data store. Now this one becomes a little bit more difficult because you might say, oh, well, wait a minute. I have customer data and I just need to store it. The customer data came from the external entity. But what do I need in order to store data? I need a process. Well, no, the process would be inside my system. So if we built a bubble, and we'll see this when we do case diagrams, inside the bubble is the system. Outside are all the people that can interact with the system, but aren't part of the system. Does that make better sense, Cody?
Yeah.
Okay. And then, of course, data store to data store. I mean, if anything, I need to have some process that says pull data from one data store and store it in another, right? So an example of that might be I have what's called an operating database, and then I have a warehouse, database warehouse. And at the end of the year, when we close the year, we've said in our operating database, to keep it small, we only keep 5 years of transactions, right? So consequently, on maybe December 31st, if that's my fiscal year, I go ahead and close the year, and that 6th year worth of data gets archived into a warehouse, into a database someplace else. So we create a set of DFDs. It's a graphical model of the information system based on your fact-finding results. So it's a 3-step process. We first draw a context diagram. The context diagram is missing one component. There are no data stores. It is just the system and the external entities that will react with the system. Okay? So you're all familiar with Banner. So let's think in our minds critically. I have this DFD diagram. I have this process called Banner. What are some external entities that will interact with Banner? Students. Instructors.
Other staff, I guess, and the student.
Other staff, administration, you know, financial aid might be one, right? How about the website? Accounting? Yeah. How about the website? Could we have a link into Banner to the website? Banner stores all the classes, so you know, stores all the schedules, but how is that information presented to you? In a program called Banner? Bobcat. The Bobcat website, right? So here's the deal where we have this old DOS-based archaic system called Banner that we had to build a custom interface for so that we could present the data to you on the web. Right? How convenient would it be if you all had to come up to a bay of kiosks on Saturday morning at 7 a.m. when your registration time opened and deal with a DOS-based system that you're not used to register for classes? Convenient? You know, I understand there was a time when you actually had to come up and fill out a paper to register for classes. Do you know how long ago that was? You could still do it when I was a student as a means of bypassing how slow the stinking system was. So one Saturday morning, I log into the system. It won't log me in. It won't log me in. It won't log me in. I'm at the end of my degree. I've got some classes I have to take. It was during one of those peak periods where getting into classes was tough. I was freaking out. Oh, get in the car. Oh, drive up here. Fill out the form. Oh, got my classes. And what did the person say when I ran up here? Why didn't you do it online? I'm like, because I couldn't do it online. Oh, you don't know how? No, I'm a CIS major. I don't know how. So then we draw a diagram 0. We'll talk about that. And then we start drawing the lower level diagrams. Until what? What do you think? Until we've...
all the information is documented for the whole process.
Right, until the entire system is documented. So think about this if we were documenting building an engine for a car. Okay, whatever level it is, you know, there's the context diagram is the car, right? And we're like already 50 levels down when we finally design the engine. Now let's go design all the parts for the engine. You see how many levels that could take? Does that example make sense, or do I need to give you another example? Are we good? Are we going to have to do push-ups this morning? Because I've had an energy drink. So creating a set of DFTs. So guidelines. Draw the context diagram so that it fits on one page. Woo! Well, that should be pretty easy. We have only one process called the system. Use the name of the information system as the process name in the context diagram. Yep, that makes sense. The system. So in personal trainer, our case, what's a good name for the system? Give me some ideas. It's not anything. Use the name of the information system. So what's a good name for this information system that you all need to create for personal trainer? Personal trainer system. Oh, that's obvious, but there you go, right? Or personal trainer management system. If we're going to do everything in one system, personal trainer ERP system, right? You know. Use unique names with each set of symbols. Okay. A lot of times the names that we start giving these processes and that we give the symbols become the variable names and become the process names, right? Call, class, whatever. This is really tough to not cross lines. Okay. Sometimes we have a little symbol that we use, but think about how complex some of these processes can be, how many inputs we have, how many data stores, how many processes of processes. How how are we going to not cross some lines? Well, sometimes it's as easy as just moving some things around and taking the time to do it right. Why don't we want to cross lines? It makes it more confusing. Yep. So provide a unique name and reference number for each process. Okay. Obtain as much user input and feedback as possible. So once we have this, we want to go back and say, this is what we heard the requirements for the system were. This is what we understood the processes to be. From this stuff, we can start using those DFDs as storyboards and walking people through the processes, right? So they know, you know, at some point in building an airplane, we're going to have a process that says a fixed wing, right? And if we miss that process, someone might go, you know what? We're missing a process called a fixed wing. And without that, we can't fly that plane. So here is an example of a context diagram. We have this system called grading system. Okay. If you notice, what we're missing here in the context diagram is data stores. So we have the system. We can put a logical representation around, you know, a logical boundary around the system. Data that's going to flow into the system. Well, from this grading system, we have some other system that records student records. The student may interact, the instructor may interact, and as we talked about, this grading system, we could think of it as Banner, right? In our case, though, it does more than just grades. So unique reference number for each process, and process 0 represents the entire grading system, the entire system in our case. So process 0 would be the personal trainer system. So in step 2, diagram 0, okay. So here's the context diagram for the grading system. Diagram 0 is the first level of exploding this process into whatever the main processes are. Okay, so according to this grading system, we'll establish something called establish gradebook, assign final grade, grade student work, produce grade report. What kind of high-level processes would we have in the personal trainer system? We're probably going to have a billing system. Yep, for sure. We're going to have a transaction processing system. Might we have a customer relationship management portion where we put in the people that are interested but not yet, right? So we have leads, we put in leads, and through our system, the people whose job it is to market those leads, to get those people excited so that they become prospects, so that we turn them into customers. So we might have that as a system. Might we have an inventory system?
Would that fall under transaction?
It could. It depends on how we program our system. We might find there's a reason to have inventory separate than transaction processing. Transaction processing may pull data from the inventory system and process it and put it back or put it someplace else. So could it go either way? Absolutely. You bet. So if you notice, what do you see that's consistent here between the context diagram and the diagram 0? No crossing lines. What else? All of the external entities are still represented, right? Now, what's going to happen here with level 2, okay, with this process 2, is the student and external entity going to be on that process diagram? But to be consistent, does the student record system have to be on that process diagram? Yeah. Okay. Does that make sense? We got to keep it consistent. So, oops, draw a diagram 0. So if the same data flows in both directions, you can use a double-headed arrow so that we don't have to have 2 arrows, right? Some people like 2 arrows because does it make it easier to see that data is flowing in both directions? It does, okay? So then we start doing parent diagrams, child diagrams, finally getting down to the functional primitive. What is, in your mind, in your thought, a functional primitive? Something basic. The finished output. Let's look it up. Somebody look up what functional primitive is. You might put functional primitive programming or functional primitive DFD. Da na na na. Yes. It's where you break the process down into smaller units. Very close. Yeah. It's actually when we break the process down into its smallest unit, which means we are at the bottom level. We have done it all. I'm hoping we're going to have time today to do one of these. Okay. So creating a set of DFDs, draw the lower level diagrams, must use leveling and balancing techniques. So again, if we have a process and that big process has a data store it's going to be putting into, has an external entity, as we draw the next level, okay, for leveling and balancing, we need to see that external entity. We need to see that data store. Does that make sense? Boy, I sure hope so. Leveling example. So it uses a series of increasingly detailed DFDs to describe an information system, explodes or partitioning or decomposing. So in this case, you know, we had that one process. We've taken it to the next level, okay, to a 1.1, 1.2, and 1.3. This verify order, could it have multiple processes in it? It could. So suddenly we're going to have a 1.1.1 process, a 1.1.2 process. Whew. But at the end of the day, if we've done all this work, we know that we've covered all of the requirements. We can go back to the user and say, is this what you imagine the data would need to have done to it? What we would store? Are we worried about, have we said how we're going to do this verify order process? Not yet. That's when we get into programming the system. So still, this is a black box. Don't know what's going on in there, you know. But boy, when the system crashes, where do we go look? The black box. So creating a set of DFDs, you know, here's an example of Visible Analyst, okay, which is a free tool. So balancing. You know, we've got these data stores. We've got process 1, 2, and 3, whatever those processes are, you know, and external entities that deal with the processes. So if you notice, we don't have external entity to external entity. We have external entity to a process to an external entity. Then we get down to a level where we finally define from the data store. So all we know about the data store here is that we're going to store some data from a process. Okay. Now we need to get more minuscule with this, more minute, more controlled, and define what that data is, how we're going to store it, what we accept as input, right? And how it might be output. And where it might be output too. So a data dictionary or data repository is a central storehouse of information about the system's data. What do we call this in the web world? What is data about data? Metadata. Right? Data about data. So what our data dictionary is it's metadata. Okay? So why a dictionary? Well, what do we use a dictionary for? To go do what? To look up, to define a word, right? So in this case, we're going to define data. So an analyst uses the data dictionary to collect, document, and organize specific facts about the system. Specific data. Also defines and describes all data elements and meaningful combinations of data elements. So there may be times, for those of you that have taken a database class, would we store an address in a database as 3215 Southeast 6th Street in one attribute?
Yeah.
You would?
I guess I was just thinking of example databases and that I've used in classes before. And they have,
Yep. Is that really normalized though?
I guess not. I guess you'd have like the house number and the street or something.
You'd have the house number and street, right? Because is it possible that I want to call up? First of all, we have two different types of data there, right? We have a numerical value and what? A string of variable characters. We have a variable number, because can somebody's address be, 123 Southeast 6th and another one be, 15678 Southeast 6th?
What would you do if you're doing like mailing addresses and they have like PO boxes?
All right. What would you do?
I guess that's why I was thinking it'd all be in one column, because that way you'd be able to store both those.
Okay.
types of addresses.
All right. So in one column, I could store both a PO box, and so I would say PO box 157, right? Or address 1525 Southeast 6th. Maybe so. But how much data do I need to sort through if I want to get just people who have PO boxes? Would it be faster for me to have an attribute called PO box, and if they don't have a PO box, have a null value in there? Is it quicker to sort through null values than it is to sort through a bunch of data that I know I don't need? Okay. So back to the address part. You make a great point. Great point. Back to the address part. Is it possible that I want to query all of my customers that live on Southeast 6th Street? Yes? Okay. How hard is it to write that query if I have a variable number sitting in front of it? Right? It is hard, isn't it? Right. So I could sort through the whole string and say, give me results where you find this. Or I can just say, and not only do I need to do that, but I need to say, forget the information on the front. And by the way, look and see where the first space is. Do y'all know how that happens in a query? How does it happen? How do we find the first space? Huh? Location? Does it go and say, is there a space after the first space? Nope. Is there a space after the second space? Nope. Is there a space after the third space? Nope. Is there a space after the fourth space? Yep. Okay, then take whatever's after that. Here comes the next record. Is there a space after the first space? Right? Don't I get rid of that if I normalize the data? Yeah. Are there other examples of that? Could I normalize a phone number? Area code. Would I ever want to pull from a database? Give me all my customers in area code 541. Yeah. So a data element, also called a data item or field, is the smallest piece of data that has meaning. So we just had that address and broke it up into two smaller pieces that both have meaning. Street number, address name. Cool? Data elements are combined into records, also called data structures. So what's a record represent? What's a record represent? So a record is let's talk Excel. We're all familiar with Excel. Okay. So an Excel spreadsheet represents a table. Okay. A column would represent what? An attribute. A row represents a record. What might we put in a row in my Excel spreadsheet called customer information? Names, phone numbers, address, customer ID, email address, cell phone number, Twitter handle, maybe. So a record is a meaningful combination of related data elements that is included in a data flow or retained in a database, in a data store. So in that customer Excel spreadsheet, would I next to each customer list every single order that they've placed? No, because isn't that logically different data? And there's the possibility that one customer can place how many orders? Unlimited. Many is what we call it, right? So we can define our system that says a customer is only moved to the customer database from the prospect database when they do what? Place an order. Then they're a customer. Until then, they're just a prospect, and we can spam them all we want. But as soon as they become a customer and buy something, we'll quit spamming them, hopefully. Have you ever ordered something and then you just start getting all these emails from, it's like, really? I wanted this one thing from you. You know, now I've got to spam you. So a record related to combination. So data dictionary uses case tools for documentation. The more complex the system, the more difficult it is to maintain full and accurate documentation. As we're programming this, couldn't we find that we need to make changes? We got to make sure to go back to the documentation and update the documentation. Modern case tools simplify the task, yes, because they remind us of what the elements of the data was, what we've changed it to, etc. Okay. Who's going to use the data dictionary first? What's that? Management really wouldn't use the data dictionary. Before the database manager, a database programmer is going to use this data dictionary to program all the tables, all the attributes, all the records that we need for our database, right? And that might be one big, can we have all of the data stores for the personal trainer system in a single database? Yes. Now, think about Facebook and how huge that database is. Think about all the functionality of Facebook. And how does Facebook make their money? They query the database and sell it to people who want to do what? Advertise. On your wrist, what kind of watch is that?
LED watch.
It's what?
Just an LED watch.
Oh, LED watch? Okay.
Yeah, it's not a smartwatch or anything.
Okay. I thought it was a smartwatch. I was getting all excited. Class dismissed. Let me see your watch. All right. So you'll learn more about case tools in part 2 of the systems analysis toolkit. So a data dictionary, here's an example. By the way, we do not need some fancy tool to do a data dictionary. Okay. I do not know why they're showing Outlook, but what might be a good Microsoft Office product to create a data dictionary in? Excel? Yeah, I think so. Yeah. Excel would be awesome because then we could start sorting the data, right? And asking questions of our metadata, which is information about our data. The first thing we might ask is, if I was working on this part of the system and you were working on another part of the system, right? Is it possible that we find out that we both created a data element that is pretty much the same data? So what would we want to do? Normalize it. Hey, you need this data. I need this data. Let's store it over here one time and we'll both access it in our process. And what happens to our system's performance when we do those kind of things? Yeah, ching, ching, ching. So I'll give you an example of that. Oops. I just want to make myself a note. Yeah. It's an A. So the following attributes, hey, stop. Thank you. The following attributes usually are recorded or described. So a data element, we've got to give the data a name. Okay. A lot of times, these are the names that become the column headings, the attributes, right? So we could have, by the way, are we going to store a customer name as the full name? No, first and last. You bet. And if there's a middle initial, or if there's a prefix or a suffix, right? Mr. Eric J. Magidson. How many attributes might I have there? 4. Yeah. And why do I do that? So easier to query, right? We've normalized the database. Give me every customer who has the name Punjab. I don't know. You know, give me all my Smith customers. So the type of data, the length, the default value, acceptable values. Regular hours. So we have a place for data input of regular hours, and then only the manager can see the overtime hours. So I have a managerial assistant who takes all the hours for 400 employees and manually enters them in the system because we haven't gotten a swipe card thing yet. And then the manager enters the overtime. So what would be our limits on the regular hours? According to, I think it's a federal law, isn't it?
I think it kind of varies. I guess the overtime work kind of varies by state. I know where I worked in California, if you work more than 8 hours in a day, then it was overtime.
Uh-huh.
It's a union. It didn't have by a company.
So it may be by company, yeah. So attributes usually are recorded. So the source, where is the data coming from? How do we need to secure the data? You know, what users can access the data? So would we have a regular user accessing overtime data? Probably not. And the description and comments. This data element was changed from 8 characters to 9 characters. Do y'all remember when one data element had to be modified in a ton of systems? Y2K. Because nobody had the forethought to think that these databases would still be functional in the year 2000. Trying to get through the lecture and then I'll shut it off and we'll talk a bit more. So documenting the data flows. So, you know, the data flow name or label, the description, the alternative names, you know, if we're using data with 2 names, the origin of the data, the destination, where it's stored in a record, the volume and frequency. If you think about it, we need to know how often we're going to be accessing this data, right? Is it one time a month? Is it one time a day? Is it one time an hour? That may decide where we start normalizing our data, right? It also will decide if I'm constantly getting at this data, I don't want to have to pull it each time by reading and writing to a disk. So a lot of times now databases have what? If we don't want to constantly get data, what do we put it in? You all have this on your computer.
History?
Not history.
Cache.
Cache. We put it in cache. And cache normally is stored in primary memory for all of you that have taken 120. Because primary memory is much faster to read and write than secondary, right? Typical characteristics of a data store. So a data store name or label, the description of the data store, alternative names, attributes, and volume and frequency. So what's a data store? A table. And then we start listing everything under the data store, and then we take the data elements and give information on each element. So what are we doing? We're leveling. So typical characteristics of a process in the data dictionary. If we have data, we then list the processes that are done against the data. The description, the process number, the process description.
So is this all of these within the data dictionary?
It's all within the data dictionary.
And that's used, so these entries are going into are created with a case tool? Is that what?
They can be created with the case tool, or again, we can do them in Excel. You know, we could make a list in Word if we wanted to. Not very efficient though, but we could.
That screenshot is coming from a case tool?
Yeah, it's coming from a case tool. Yep, you bet it is. So we have description, verify order. It's a process. Input data flows. So the data flows from order, from credit status, from product detail, and it gets output to rejected order or accepted order. So we have some data coming in. The process does what it does. The process is simply to accept or reject customer order based on credit status and product availability. Now I look at this and go, wait a minute, we might need a sub-process of this. Or I might program into this process to say, am I really going to reject an order just because I don't have the product on hand? You know, I ordered a hat for my son's birthday, and they sort of forgot to tell me when I ordered it that they didn't have it in stock, and thus I was waiting to get it. And then I didn't get I got a confirmation, your order has been placed, but not a confirmation of when it was shipped. Guess what I ended up having to do? Call the company and say, what's going on with my order? Oh, well, Duke just won the national championship. We don't have that hat in stock. Well, could you develop a process that says, I'm sorry, I don't have the product in stock. Do you want me to back order it for you? Or would you like me to cancel the order? Would that have been a good thing to do? Yeah. But why don't companies want to do that? Because they'll lose the order. But guess what this company lost instead of, yeah, continued orders. You bet. And if your business is customer centric, which most of them are, you better treat your customer right. Have our expectations of how we're treated changed because of the internet? When do I expect to know that my order got placed? Right away. When do I expect to know when it's going to ship? Sometimes right away. We will process it. It will be out the door in a day. Whew. And what else do I want to know?
Estimated delivery.
I want to know the estimated delivery time. Yep. And then what do I want to know from FedEx or UPS? I want to know where it is, because I'm waiting for it. I want them to send me an email or a text every time it changes locations. And I finally want to know when it got delivered at my door. So typical characteristics of a record. So we're breaking that, that data store down to a record and then finally to attributes. Pretty simple. So data dictionary reports. Once we have the data dictionary and a database programmer has designed our database, all of the tables, whatever we need, all of the processes based on our data dictionary, then a report writer will go and say, now that we have all this data, what do you want to know about the data? Okay. There are folks that this is what they do all day long. People come to them and say, I need a report that does Now, hopefully, they've also created a dictionary called a report dictionary. And they go query that before they design another report, because what they might find out is the report that they've already designed for marketing might also work for quality, because they're both asking for what? The same data. And if not, maybe I can run that report process, okay, and take off the data that they don't need. Do I need to go through programming a whole new report? No. So detailed reports showing characteristics of data elements, records, data flows, processes, whatever the report needs to say. Most of the time, okay, we have different types of reports. We can have reports out of our database management system that tells us how long it takes to process a process. And if it's too long, maybe we can find a way to shorten it. So process description tools document the details of the functional primitive, that last element, which represents a specific set of processing steps and business logic. Should be noted that this chapter deals with structured analysis, but the process description tools also can be used in object-oriented development, which we'll describe in step 6. If you think about it, what we're designing, a programmer can take and start creating objects based on this. So in my database, I'm going to need a record. I'm going to need a table called customer data. Don't I also need an object then called customer data? Because I need to somehow get the data from the object, pull the attributes, and in that object process, store it in a record. Maybe part of that process is enter new customer. What's something I might want to do before I enter a new customer? Make sure they're not already a customer. Have you gone out to a website that you forgot you placed an order at and you put in your email address and they go, we already have a customer record for this? Now, a couple things have happened for me. Okay. I actually had a deal where I had never placed an order there. So I was wondering how they got my email address. I got a little worried. So I emailed this guy I know named Eric Magidson. He lives on the East Coast. And I said, I was placing an order. I'm a little worried. I'm worried about data fraud. Did you place an order? He says, yeah. And I said, well, instead of putting in Eric_Magidson@gmail.com, you put in Eric.Magidson@gmail.com. That's my email address, buddy. I still today am getting receipts for his part. He must have a car and he lives in New York, which means he pays for parking. This New York Central parking. I get his receipts. I also know each time he goes to the dentist because I get reminders of his dental appointments. You know, so I'm a nice guy. So, you know, I'll just email him and say, hey, you know, hope nothing major's wrong. You know, I'm trying to remind him to go change the damn thing, you know. And a couple other things he's signed up for that I've just had to spam. So modular design based on combinations of the 3 logical structures, sometimes called control structures, which serve as building blocks. So we have a sequence structure, a selection, and an iteration, a looping, right? How many have taken the 122 class? What's that first loop you do? Have you all done, I don't know if they still do it. Do they all do the hello world? Your first program is hello world, and what happens? It continues to loop forever, right? And then you learn to take that loop and say, do this process 50 times, and 50 hello worlds show up. And then we add the if statement. If it says hello world, do this. If it says goodbye world, do this. And we start designing programs. Except for me. There's a reason I teach networking as a systems analysis. I am not a programmer. It's just not for me. So structured English must conform to the following rules. So, you know, as we get better programming languages, we start getting closer to what's called natural language programming. How many people could suddenly become programmers if I could write program code that says store customer name in customer table? And suddenly, what does it do? It writes the back-end code that does that. Have we gotten closer to that? How did we used to have to program it? At what language? At what level? Binary. Punch cards. Yep, that's my dad and my uncle. When they went to school and they wrote their first program, you know, I don't remember if it's, I think it's punch it out if it's a 1, leave it non-punched out if it's a 0, right? And write your whole program in 1s and 0s. Okay. He at one point still had one of those paper boxes that had all of his punch cards to do basic addition. And I'm like, dude, how easy do we have it today? Huh? So use a limited vocabulary, including standard terms used in a data dictionary and specific words that describe the process. We need to be consistent. And it needs to be readable. Should I call my customer name method XYZ165? Probably not. So structured English might look familiar to programming students because it resembles pseudocode. So if customer is preferred customer, and if customer orders more than 1,000, then apply 5% discount. If customer uses our charge card, then apply an additional 5% discount. If customer orders more than 1,000, no, they didn't. Else, customer must have ordered less than 1,000. Apply a $25 bonus coupon. If the customer is not a preferred customer, they're just a regular customer, we're still going to give them a $5 bonus coupon off their next order. Y'all shop anywhere where at the end of the transaction, they're like, hey, here's $5. It starts tomorrow. Get $5 off a $10 item. Why are they doing that? Keep you coming back. You know, how many people take advantage of those? I do too, you know, when it's really convenient. Yeah. And what I've done is manage my shopping sometimes where I know I'm about to get $100, and today they have a thing that if I buy $100 today, that bonus coupon becomes $40 off 100, you know. So I really want about $200 worth of items. Today I'll buy the 100, so I get the coupon to buy the other 100. You know what sucks? Is sometimes they can't figure out why can't I just got the coupon. Why can't I just do this today? Why not? I'm not going to come back. Well, guess what? If I don't buy the other 100 today, I'm not going to come back. You see my point? So I have had a business that was willing to take my transaction, and because the system was designed to where they couldn't process the process discount till tomorrow, they allowed me to leave the store. They had my information. I was happy to give them my information. They processed it the next morning. But didn't that create more work for them? It did guarantee me coming back. So decision tables. So the number of rules doubles each time you add a condition. Well, didn't we notice what happens exponentially when I add one more person to my communication matrix? It's the same thing here, right? If I have a yes or no, I have 2. If I have a no and something else that happens because of the no, that's got to be something happens if it's no, something happens if another condition. I just doubled my conditions. Can have more than 2 possible outcomes. Here's the disadvantage. Somehow in a system which only recognizes 2 things. What?
True or false.
Or on or off, open and closed, right? 1 and 0. How do I program a maybe in there? Else, through a decision table. So often our best way to describe a complex set of conditions. Yes. So here's an example. Are they a preferred customer? Yes or no? If no, 5% bonus coupon. This is what we're just looking at. Ordered more than $1,000. Well, that must be what makes them a preferred customer, right? If so, did they use our credit card? No, just give them a 25% bonus coupon. Yes, which means if they use my credit card, there's a chance I'm going to collect what? More money from the transaction through interest. Yep. So I'm willing to give them a bit more. A 5% discount and an additional 5% discount. They didn't use the credit card, but there's still a preferred customer, just the 5%. So logical versus physical models. So while structured analysis tools are used to develop a logical model, logic, what's in our head, right? Bringing it out in a graphical form. For a new information system, such tools also can be used to develop physical models of an information system. So this is where, based on that logical model we can pull that data and literally start creating the code that will be the physical part of the system. Now, this can be very, very hard for people to understand. Most people outside of IT look at software and say it's all logical. But someone had to do what? What makes it physical? Nope. Close. Someone had to do what? Build it. Someone had to program it. You see that? Can I have an idea in my head that's a logical idea of how a house should be built? It only becomes physical when someone does what? Builds it. So sequence of models, many systems analysts create a physical model of the current system and then develop a logical model of the current system before tackling the logical model of a new system. Whew, that's a lot of work. Maybe the physical model already exists. That's a database. I know that I need to take all the data from this database in this data dictionary and transfer it somehow to my new database. That way we don't have the old system that Chad has to reference and the new system, because that's going to piss Chad off, especially when I can do a process called data conversion. But what I need to know is this element of data that was called customer name in this table needs to go over in this table to what I've called cust underscore name, right? And then I need to make sure, well, wait a minute, do the elements of the data match? Maybe I'm only accepting 8 characters. This one accepted 10. May I want to change mine so that I can do a clean data conversion? Yeah. Can you see how complex data conversions can be? Can you see why most data conversions only convert the data you absolutely need into the new system? This is a timely, costly process. And if you're waiting for this to be done before you can fire up the new system, woohoo, you might be waiting a while. So performing the extra step allows them to understand the current system better. You bet it does. However, they've just spent a ton of resources doing this on the old system. One hopes that there's documentation on the old system, because then I don't have to do this. But I can refer to that documentation and the processes in the data dictionary because I might, in my new system, have the exact same process. Agreed? Do I need to reinvent the wheel on everything? How many times do you think Microsoft has created a completely independent operating system from the one previously designed? Ever.
There's no way they could have named it Windows 9.
Sometimes it's just a marketing thing. I think they just wanted to separate themselves from Windows 8. How can we separate ourselves from Windows 8? Let's call it Windows 10. Okay. You know, So the only disadvantage of the 4 model approach is the added time and cost. Huge added time and cost. But if there's a benefit to it, let's do it. Everybody agree? Good. I'm going to stop the video and we'll do some of this. Okay? We're talked about it. Now we'll do it. Let's do it.